Quantum computing is where we utilise the unique set of rules that govern matter on its smallest scales in order to perform and run calculations. The idea behind us wanting to do that is we'll be able to potentially outperform the fastest supercomputers in certain applications and potentially even solve problems that would be impossible otherwise with our current classical computing technology.
It's critical that defence starts to look now at what the applications could be for quantum computers. So DSTG, along with ASCA, are running a number of projects to investigate different aspects of quantum computers. With the University of New South Wales, we're investigating a novel form of error-protected qubit. With CSIRO and the University of Western Australia, we're looking at potential applications for quantum computers in machine learning and optimisation. And with Monash University, we're looking at the types of error correction which could be useful in specific applications.
Quantum computing has the potential to take certain problems that are extremely challenging or even impossible for our current computers to solve and solve them very efficiently. As early as the 90s with Shor's algorithm, we've known that they'll be very efficient at cracking encryption protocols, and that sparked the whole field of post-quantum cryptography just to kind of defend against them. And since then, the different areas and problems quantum computers are expected to excel in have only continued to grow and include things like accelerating scientific simulations, particularly in material science, solving advanced logistics and optimization problems, and even the fields of machine learning and artificial intelligence are expected to be able to benefit, all of which can have a massive impact to defence.
Army has investigated the use of quantum computers to optimise logistics systems. So imagine exercise talisman sabre where there's thousands of vehicles being moved across Australia. The question is, how do you schedule and route all those vehicles so that they all arrive at the training area safely and in the right order? That's a really difficult problem. We did work with a number of companies investigating the use of quantum computers to optimise that really challenging problems and to work out when quantum computers will really deliver a performance advantage in scheduling and routing all of those vehicles.
We don't yet know what a quantum computer will do, but that's similar to where we were 60 or 80 years ago with classical computers. No one knew what their potential was, and they have drastically changed the world in which we live. It's possible that quantum computers could do the same thing, and that's the reason that technology multinational companies like Google, like Amazon, like Microsoft, like IBM are investing large amounts of money in quantum computing. And it's critical for us to make sure that we keep up to date with those changes, and it's critical for Australia to maintain a capability to both build and utilise quantum computers.